Hello there and welcome to another tutorial. In this tutorial we're going to create a very simple little health system. So we have this health bar here with the green area representing how much health we have. We have our player object over here, and then we have a trigger box area which will apply damage to our player object when it moves through the area like so. And we can see the green area and the health bar depletes until we run out of health, at which point the health bar will disable and we will get a message sent to the console window saying that the object has died. Okay, so I have a blank scene here. The first thing we're going to do is we're going to build the UI. So I'm going to right click in the hierarchy window, go down to UI and select canvas. We'll call this canvas overlay. Okay, so with the canvas created, the next thing I'm going to do is I'm going to change our scene viewport mode to 2D by selecting this button at the top. It says 2D. Select that, and then we'll double click on the canvas to focus our view on it and make sure that it's all in the screen. So this rectangular area is the area that the canvas will render UI objects. Because we have this set to screen space overlay, we can basically think of this as our computer screen. Looking at the canvas object, we have a few components. It has a rect transform, which is basically just a 2D user interface sort of version of a transform. We can see that we've got the position, just like a regular transform, the rotation and the scale as well as a couple of other UI specific options. Next we have the canvas component. So for this component, we just want to pay attention to the render mode for this tutorial. There's three options. We want to make sure it's set to screen space overlay, which means that the contents of the canvas will project directly over the whole computer screen. The next option is screen space camera. This works in a similar sort of way to screen space overlay, except screen space overlay will project over all cameras, and screen space camera points directly to a particular instance of a camera. The third option is world space, so we can use this if we want our user interface to exist in the 3D world space of our game. This can be useful for things like health bars and nameplates and that sort of thing that exist over the tops of enemies and move around in the world with them. Also, you could use it for like an interactive screen in the game and things like that. The next component is the canvas scaler. So the canvas scaler is responsible for defining how your UI will scale with different resolutions and screen sizes. So for this one, we are going to change the UI scale mode to scale with screen size. And this means that we provide it with a reference resolution and it will scale up or down based on that resolution and according to the other settings that we define. So the reference resolution I enter here will be standard HD, so that is 1920 for the width or the X and 1080 on the Y or the height. Next we have the screen match mode, so there's three options here. We have it set to match width or height, which means it will scale up or down based on the reference resolution that we've passed to it. There's also expand, which means it will never get smaller than the reference resolution. And there's also shrink, which means it will never get larger than the reference resolution. We're going to leave this set to match width or height. But here we have to set an actual match value. So if we set it to 0 or over to width on the bar here, that means that it will only scale depending on the changes to the width of the screen. If we drag it all the way up to height or give it a value of 1, it's the same thing, but it'll only change based on the changes to the height of the screen. For our purposes, we want to make it a split even ratio between the width and the height of the screen. So we're going to set this to a value of 0.5, which is exactly in the middle of the two. The last component attached to the canvas is the graphic raycaster, which gives you the option to make your UI elements interactable. So the next thing we're going to do is right click on our canvas in the hierarchy window and select create empty. We will call this health bar, and this is going to be the container object for the two images that will make up our health bar. Now if we look at the rect transform for this object, let's run through the various properties that UI transforms have extra. So first of all, we have the anchor point here, which is represented by this image. It's by default set to the middle. If we left click on this image, we can change to a different option. So the anchor for a UI element basically defines the position of the origin point for that particular UI element on the canvas. I'd like my health bar to be more towards the top of the screen, so I'm going to anchor it in the center but at the top. But before I select this option from the anchor selection menu, I'm also going to hold left shift so I can set the pivot point for the object at the same time, and left alt so that it also snaps the object's position at the same time. So after holding in left shift and left alt, we'll select this option here. And we can see that our object has now been anchored to the very top of the canvas and its position is still 0, 0, 0. So let's say we wanted it to have a slight buffer from the top of the screen. So we wanted it to move, say, 25 pixels down from the top of the screen. On the Y position, we can now enter -25, which will move it exactly 25 pixels down from the very top of the screen. The next values we're going to look at is the size dimensions of the UI object. So these values should correspond directly to the resolution or a multiple of the resolution for the image that you're going to be using for this UI element. In this case, I have a red bar and a green bar that are both 1000 pixels wide and 50 pixels high. So that's the resolution I'm going to give to my size dimensions here. So we'll go 1000 for the width and 50 on the height. So now that we've defined the overall size of our health bar, we can now create a couple of images for the foreground and the background. So we're going to right click on our health bar object in the hierarchy, go to UI and select image. So the first thing we need to do for this image is we're going to name this BG for background. And the next thing we need to do is change the resolution or the size dimensions up here to match the size dimensions of our image and our health bar at the top. So that was 1000 by 50 for the height. Okay, so now we want to feed our images into the source image property for the image component. But if we try and drag the object into the source image property with the default settings, we can see it won't accept it. So what we need to do when we import images for UI elements, in the projects window, we will select one of them, and we need to change the texture type on its import settings at the very top. So we'll open that menu, and the option we want to select is a sprite, which is 2D and UI. So sprites are 2D images that are used for 2D games and also for user interface elements. So we'll select that, and then we're going to hit apply. And we'll do the same thing for our foreground image. So with the import settings correctly set, we can now go back to our background image and drag our background sprite into the source image slot, and we can see that our health bar has now got the red image applied to it. So now we need another image that's going to be drawn on top, right, which is the green bar, and that one will move up and down and reveal the bar behind it depending on how much health value we actually have. So we can easily duplicate this object by making sure it's selected in the hierarchy window and then pressing Ctrl D on the keyboard. I'm going to rename this object to FG for foreground. And the next thing I'm going to do is drag my foreground image from the project window into the source image property. We're almost done with setting up the images for our health bar. The last thing we need to do is change our foreground image so that we can dynamically change the portion of it that is going to be rendered at any given moment. So what we need to do with the foreground image selected is in the inspector, for the image component, go down to the image type and change it from simple to filled. This will reveal a few other properties that we can change. But the main thing is the fill amount. This is what we need to dynamically manipulate through our scripts. So if we change this value, we can see that it changes the amount of the image being rendered. But this radial fill is not exactly how I imagined this health bar working. So what we're going to do is change the fill method from radial 360 to horizontal. I'm going to leave my fill origin set to left, but what the fill origin does is it defines the direction that the bar will deplete. So now that we can change how much of the health bar is going to be rendered, we can start programming. So what we need to do is right click on our assets folder, go to create and select C# script. And I'm going to call this script UI_HUD for heads up display. We can then open this script in Visual Studio. So the first thing we need to do to be able to program with Unity's UI elements is inherit from the Unity Engine UI namespace. So at the very top of our script, underneath where it says using Unity Engine.ui, we want to write using, followed by Unity Engine, then .ui. The next thing we can do is get rid of the update and the start function because we don't need either. Next, we can begin defining the required variables. The first variable is going to be public so we can see it in the Unity inspector, and it's going to be of type image. And we will give this the name health bar FG for health bar foreground. This will store a reference to our foreground image object so that we can manipulate the fill amount through code. The next variable we're going to create will be a static variable. This means that rather than accessing the variable through an instance of our UI HUD class, we're going to be able to access it directly through the class type itself. This allows for really easy access to any of the variables within our UI HUD class, but we need to keep in mind that static variables are shared between all instances of the class they're defined within. This means we will need to make sure that there will only ever be one instance of this class active at any point in our game. We're also going to make this static variable an auto property, which will provide some extra protection by allowing it to be publicly accessible, but only privately settable. That means that other classes and scripts will be able to read this variable with no problems, but the value of the variable can only be set within this script. So to do this, we'll first start by making it a public variable, followed by the static keyword to make it static. We're then going to use the class type of this class, which is UI_HUD, and we're going to call it instance with a capital I because we're making it an auto property. Then to actually make it an auto property, we open a set of coding brackets. And the first thing we have to define is the getter. So we can simply write get followed by a semicolon. Then we need to define the setter. So before we write set, we're going to define the protection level as private and then follow that with the set keyword and a semicolon. So by not defining a protection level for the getter, it automatically defaults to the protection level of the variable itself. And by defining the setter as private, it means that we can only set the value of this variable within our UI HUD class. Okay, so we're going to need three methods for this class. For the first method, we will simply inherit Unity's awake function. And within this function, we want to set the reference for our instance variable. So to do this, we can simply say instance is equal to this. The next function we're going to write will be responsible for updating the value of the health bar fill amount. So underneath our awake function, we're going to write a public function which will return nothing, so it'll be of type void. And we will call this function update health. This function will need to take two parameters. They will both be of type float, and the first one will be the current health value, and the second one will be the max health value. So we know that the fill amount has to be a value between 0 and 1. So the first thing we need to do for this function is get access to our health bar foreground image, followed by a period, and then we want to access the fill amount variable, followed by an equal sign to set the value of this. So this is a normalized value, meaning that it has to be a value between 0 and 1. So to convert our health ratio into a normalized value, we first get the current health value, then divide it by the max health value. The last function we need to write will disable the health bar. So this will be a public void, which we will call disable health bar. That will take no parameters. So the way we set our health bar up, both images are contained within an empty object, so we can simply disable the parent of those two images to prevent the images from being rendered on screen. To do this, we first get access to the health bar foreground image. We then need to get access to its transform, so we will write .transform. Then we need to get access to its parents. Now we can easily get access to the parent of an object through its transform component by following transform with .parent. This returns the parent as a transform type, and we actually need to get access to it as a game object to access the setActive functions. So we'll follow parent with .gameObject, and now we can access the setActive function, so we'll write .setActive followed by set of parentheses and pass in false to turn it off. So that's our UI script set up for now, so we can save that and go back into Unity. Okay, so I'm back in Unity, so the next thing I'm going to do is select my canvas overlay object, select add component from the inspector and look up HUD, and then add my UI HUD component to the canvas. We then need to set a reference to the health bar foreground image, so I'm going to drag the foreground image from the health bar into that slot in the inspector. Okay, so that's our user interface setup, so I'm going to close it in the hierarchy now and go out of 2D mode in the scene view by clicking on the 2D button again. Now the next thing we're going to do is create an object to represent our player. So I'm going to right click in the hierarchy, go to 3D object and select sphere. So next we'll quickly reset the transform component to 0, 0, 0, and then I'll double click on the sphere in the hierarchy to focus on it. Then in the inspector, we're going to remove the sphere collider from the object. We're going to select add component and look up character controller and apply that to our object instead. So the next thing we need to do is write our health script for our character. So I'm going to click the add component button here and type in character health, select new script, and then select create and add. So that's created the script and added it to our player object. So now we'll open it in Visual Studio. Okay, so this class is going to be responsible for managing the player's health. So first we'll get rid of the update function. Next, at the top of the class, we're going to create some new variables. The first one will be a public float, which we will call max health. I'm going to give this a default value of 100 as well. Next, we want a private float, which we will call current health, and give a default value of 0. Now it's important that current health is a private variable because we only want this script to be able to manipulate the value of that variable. Okay, so with our variables defined, we'll now move down to the start function. So the first thing we want to do is set the value of our current health variable equal to our maximum health variable, because at the beginning of the game you generally have full health. So we can do this by accessing first current health and simply saying that it's equal to max health. On the next line, we're going to set our health bar fill amount so that it is also completely full. So to get access to our static reference of our HUD, we first access the type, which is UI_HUD, followed by dot, and then we can access any static variables directly through the type. So we have our instance variable here. After we get access to our instance variable, we can then access all of the plain methods that we wrote in it. So in this case, we want to access update health. And this takes two parameters, first the current health and then the max health. So we'll pass it current health first, followed by a comma, and then max health as the second parameter. And that's all we need to do for our start function. Now the next two methods that we write are going to be responsible for applying damage to our character and also for the death of our character. So the next method we're going to write will be a public boolean, because it's going to return true or false depending on whether we were able to successfully apply damage to the character. We will give this function the name onDamage, and it's going to take one parameter, which will be a float, and we'll call it amount, and that's going to be a representative of the amount of damage we're applying to the character. So the first thing we need to think about when we're trying to apply damage to the character is that we want to make sure that the character is actually alive, that they have health. So we'll open an if statement, and the condition for this if statement will be if current health is greater than 0. So if current health is greater than 0, then we know that we have health to take away. So here we're just going to simply say current health minus equals and then amount. So that's going to subtract the value of this amount parameter from whatever the current value of current health is. Now after this, we're going to need to perform a check. So we're going to open an if statement. And the condition for this one is we're going to check to see if current health is less than or equal to 0. So if we've run out of health essentially, because if we have, we want to make sure that we cause our character to die. We also want to make sure that the value of our current health variable can't actually go below 0. So the first thing we're going to do is we're going to make sure that current health is at a minimum set to 0. Then after that, for now, we're simply going to write a comment and just put death. So after making sure that the value of our current health variable has been clamped, we can then update the user interface, the health bar, after this. So outside of that if statement, but still within the if current health is greater than 0 if statement, we're going to access our HUD class. So we'll go UI_HUD, followed by a dot, and then our instance variable. Then after that, we're going to call update health again, and pass it our new current health value and our max health value again. Now, if the code manages to execute this little if statement block that we've written here, that means that we were successfully able to apply damage to the player character. So here we're going to get the function to return a value of true. Now we still have this function returning an error, and that's because not all potential ways that this method can execute will return something. For argument's sake, let's say that our current health is not greater than 0. That means that this block of code will not actually execute, so the function never returns something. So outside of this, if current health is greater than 0 statement, underneath that, we're going to simply say return false, which means if that if statement doesn't execute, we're going to return false because we were unsuccessfully able to apply damage to the character. Now the last method we need to write will be a public void, and we'll call this onDeath, and it won't have any parameters. And this function is going to be responsible for killing our character. So all that we're going to have happen when the character dies for this tutorial is we're going to disable our health bar and print a message to the console. So the first thing is we need to get access to our UI HUD class again and the instance static variable. And then from that, we're going to call the disable health bar function, which doesn't take any parameters. So that will disable our health bar. And then after that, we're going to call a debug.log to print a message to the console. And first we're going to pass the name of whatever game object this script is attached to. So we'll say game object with a little g to get access to this particular instance of the object that the script is attached to. And then we'll say name to access its name. And we're going to concatenate onto the end of this a little string. So I'll put plus and then open some quotation marks. And first I'll put a space to make sure that there's a space between the name and our message. And then I'm simply going to write has died before ending the line with a semicolon. So the last thing we now need to do for this script is come up to our death comment and replace it with a call to our onDeath function. And with that done, we can save our script and head back into Unity. So now we're back in Unity, let's just select our sphere and double check our settings. So our character health script is attached to the object and we have a max health value of 100. So if we hit play now, our health bar should update to be full. So let's give it a go. And you can see as soon as it starts, the health bar is updated to be full. So outside of play mode, I'm just going to rename this sphere to player to be a little bit more clear. And the next thing we need to do is create our damage trigger object. So we'll right click in the hierarchy, go to 3D object and select cube. And we might as well reset the transform to make sure it's at 0, 0, 0. Then we're going to move it away from the player on the x-axis a little bit, and we'll reposition our camera so we can see them properly. Okay, then we'll rename this object to damage trigger. Now the next thing we need to do is make sure that our collider is set to be a trigger rather than a physical collider. So for the box collider component, we want to make sure the isTrigger property has been checked. This will allow the collider to still be able to register when something hits it, but it won't physically stop that collider from being able to move through it. And the last little thing I'll do is I'll just change the default material for our damage trigger. And I'm going to set this to the default sprite material because it's like kind of transparent. Okay, so our cube is nearly ready to go. The last thing we need to do is write the code that's going to define what happens when something triggers the trigger and apply it to this object. So we'll select add component and we've got to create a new script here. So I'm going to call this damage box. Okay, we can see that our damage box script has been applied to the object. So now we'll open it in Visual Studio. Okay, this is going to be a very simple script. The first thing we can do is get rid of both the start and the update functions. The next thing we need to do is define a public variable of type float, which we will call damage. And that's going to store the amount of damage that that this trigger actually applies to a character. Then underneath that, we want to inherit the onTrigger enter function from the monoBehavior class. So this method is called on the frame that a collider on a separate object enters the collider of the object that this script is attached to, provided that this script's collider has isTrigger set to true. The collider of the colliding object is stored in this other parameter. So what we need to do when an object collides with this one is check to see if that object has a character health component attached to it. So we can do that by opening an if statement, and then we're going to use the other parameter to get a reference to the object colliding with this one. And we want to try and get the component character health from it. So we're going to use the try get component function. Now in here, we need to first declare the out keyword. So it's going to push the component, if it's able to find it on the object, to the variable that we're about to define here. So this variable will be of type character health, and let's just call it health, right? Then between the last two parentheses here, we're going to say equal to true. So basically this line is saying if we can get a character health component from the colliding object, we're going to store that component in this health variable and run the following code. So if we are able to get a health component from the colliding object, we can access that through our health variable. And then we simply want to call the onDamage function and pass our damage amount to it. And that's the entire script. And that should be everything done now. So we can save that and go back into Unity. Okay, so I'm back in Unity now. So we'll just double check a few things. Let's select our damage trigger object. And first we need to make sure we actually set a damage value because we didn't set a default amount. So I'm going to set mine to 20 damage. We also want to make sure that the box collider for our damage trigger has isTrigger set to true by checking the box. The next thing we need to check is on our player object, and we need to make sure it has the character health script and it has a max health value above 0. We also need to make sure that it has a character controller component attached to it so that it can actually register collisions with that inbuilt collider. You could also use the normal sphere collider, but you would also need to attach a rigid body to that in order for it to be able to register collisions with triggers. The last thing to check is to make sure that our UI HUD still has its reference to the foreground image of the health bar, which it does. So now let's hit play and see what happens. Okay, so our health bar is full now that the game is running. So if I select the player object and I move them through our trigger collider, we can see we take damage. We take some more damage every time we move through. We go one more time. I'll swap over to the console here. We'll move through one more time. We can see that we get our player has died message to the console and that the health bar gets disabled from the UI. So that's it for this really simple health system. I hope you find this useful. Thank you for watching. Please leave a like if you enjoyed the video or a comment. If you haven't subscribed and you enjoy my tutorials, please subscribe as well. It really helps me out. Thank you very much for your time.